This is Algebra 2, Chapter 1, Section 3, in which we will be solving equations. We're going to have two main objectives: solving equations, obviously, and writing our own equations from verbal expressions, and going the other way also, taking the equation and writing the word form. So there are some terms we need to remember. They tip us off of what to do. If you see the words sum, or increased by, or more than in a problem, that means you're going to be doing some kind of addition. If it says the sum of a number and 6, you're going to write x plus 6, or some other variable for x instead of x. If you see difference, or decreased by, or less than, that's a tip-off that you're doing subtraction. When you see the word product, that's a giveaway that you're doing multiplication, and quotient signals to you to do division. So they're going to ask us to write the algebraic expression that goes with the word problem here. They want us to do 3 times the difference between a number and 8. I see difference, so that tells me I'm subtracting the things the difference is between. The difference between a number and 8. So I'm going to use x minus 8. You could put 8 minus x, but typically you go in the order they're listed. The difference between a number and 8, x minus 8, and then it says 3 times that amount. So 3 times x minus 8. The quotient, that tells me I'm doing some division of 2 things: 5 less than a number and 12. 5 less than a number is some number, take away 5. Go 5 less than that number. And this time I used n because it really doesn't matter which variable we pick. 5 less than a number and 12, the quotient between those. Some other numbers that, or some other words I should say, that tip us off to things are things like squared and cubed. The cube of a number increased by 4 times the same number. Increased is a tip-off for addition. Cube means it's to the 3rd power. So we have the cube of a number, x cubed, increased by adding 4 times the same number, 4x. They're also going to ask us to go the other way. They'll give us an equation and we have to write a verbal expression for it. What do we see in our equation? We see multiplication, 6x. Well, the way we say multiplication in words, we could say 6 times a number is 72, or we could say the product of 6 and a number. Either way. G minus 5 is equal to negative 2. I see subtraction, so I have a list of words on the previous slide that tell me about subtraction. It could be the difference in, it could be less than. I chose the difference. The difference between what 2 things? Some number and 5 is negative 2. Now they're going to throw some more properties into the mix. We last time, remember, did associative and commutative and distributive and identity and inverse. There's 3 more properties we really need to recognize. And the first one is the reflexive property. Reflexive, think reflection, think looking in a mirror. A number is equal to itself, A equals A. Sometimes you'll hear me call this the department of duh. A number is equal to itself, really? 4 equals 4? Never would have guessed. But that's called the reflexive property. The symmetric property says I can switch sides of the equation. If A is equal to B, then B is also equal to A. You can switch sides as long as you take everything from one side to the other. And then there's the transitive property. If A is equal to B and B is equal to C, then I can cut out the middleman of B and just go straight from saying A is equal to C. Another way to think about this, 2 things that are equal to the same are equal to each other. 2 things equal to the same value are equal to each other. So let's see if we can identify which property we see. If 3a minus 4 is equal to b, and also b is equal to a plus 17, then 3a minus 4 is equal to a plus 17. Both of these were equal to b, so we said they're equal to each other. That's the transitive property. If 11a plus 2 is equal to negative 3a, then we can say negative 3a is equal to 11a plus 2. What have we done? Turn the equation around. Which property turns around the equation? The symmetric property. So now we get to the main event. We get to solve some equations. And I know you already remember how to solve equations. I'm pretty sure you can handle this. I'm just showing you to remind you. And I'm going to show it in more steps than probably we need. But I would rather show you too many steps than not enough. So we have some number minus 3.24 is equal to 42.1. We need to move this negative 3.24 over. So we'll add it. And whatever you add to one side, you add to the other. And a little arithmetic tells me that n is 45.34. Remember, the basic idea for solving equations is to undo what they did to the variable. Here we've got 2/3 times y equals negative 18. They multiplied by 2/3, so I'm going to divide by 2/3. Grab my trusty calculator. Negative 18 divided by 2/3 is negative 27. Now this next one has a few more steps to it. We have 5 times x plus 3 plus 2 times 1 minus x equals 14. First thing I need to do is distribute. So 5x plus 15 equals 2 minus 2x, or plus 2 minus 2x is equal to 14. Now we can collect our terms. 5x minus 2x is 3x. 15 plus 2 is 17, and that equals 14. Haven't done anything to the right-hand side yet. Now I'm ready to move the 17 over. So I'm going to subtract the 17. 14 minus 17 is negative 3. Divide by 3 and we get x equals negative 1. They're also going to throw things at us where we're not going to get a numerical answer. And that always seems to bother people. Our goal is to solve this equation and get h alone. Well, if I want to get h alone, everything else has to go away from the h. So I need to undo some things. What did they do to h? They multiplied by some stuff, and then they added some stuff. We have to reverse the process, so we need to subtract some stuff first. So we subtracted the 2 pi r squared over. Now we need to get h alone. So we need to divide by 2 pi r. Don't make the mistake of trying to cancel the 2 and the 2, the pi and the pi, and cancel this stuff, because you can't cancel it with the s. You're stuck with it. That's as pretty as it gets, kind of like me. So I'm going to ask you to pause here and take a shot at this next one. Y equals ax squared plus bx plus c, and your job is to get a alone. Pause here, try the problem, and then we'll check your results. We want to get a alone, so we need to get rid of everything else. We're going to subtract the bx and the c first to get them out of the way. Then we want to get a by itself, so we need to divide by x squared. And again, don't cancel the x out of that, because you can't do it. It has to be able to cancel from everybody to make it work. So we learned a couple of more properties, and we converted between word expressions and algebraic expressions. And then we solved a few equations. As always, hopefully if you had questions you wrote them down. Bring those in, and we will see you in class.